I'm going to go through an example with a two-dimensional array that applies to terrain navigation. And section 8.2 describes it and actually goes through an example of this. I'm going to do it a little bit different fashion than this, and the data I'll use will be a little bit different. Try to simplify it a bit. But the basic idea is that you want to find, of some terrain, you want to find the peaks. Okay, so you want to find the high points. And the way we'll do that is a two-dimensional array will contain the peaks or the elevation levels at those points. Okay, so let's take a look. Okay, so for example, here's some numbers. I filled up a 2D array. And what these represent, if you think about this as like, a surface, think about this as like a map, right? Two-dimensional. And these are locations on a map. And so each one of these represents a location on the map. I have 25 locations, so 5 by 5, all right? And what you're going to do is you're going to compare. This is like elevation. Let's say this is 50 feet in elevation. Or not 50 feet, but these are in units of feet for elevation. This one is 50 feet. And what you're going to do is you're going to compare it with the 4 points around it, or the elevations of the 4 points around it. And from that, you're going to see whether or not that's a peak. Well, I put it in green, all the ones that you should be checking to see if they are larger or higher than any of the four around them. Because, of course, along the edges here, there's nothing else to compare it to. So I can't really compare those two. I can't make a comparison with those two to all the four elements near it. So you look for the adjacent, essentially, elements, right? So like I check this one first. So compare it to here, 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 and here. And what you'll notice is that at this point, when you make that comparison, you find out that it's not the largest because this is still larger than it. So you know this is not a peak. Okay? Then you compare this one. Do the same thing. Compare it to here, 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 and here. And at this point, 55 is not the largest, okay, because 63 is larger. Then you do the 10, same thing. Nope, it's not a peak because this is larger and this is larger. So then go down to the next row. Look at 14. And notice I put red here because those are peaks. Compared to here, nope. Here, nope. Here, nope. And here, no. So this is not a peak. So the 14 is not a peak. Then you get to the 63. Compared here, yes, 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 and yes. So now you know when you compare it to these four elements that are adjacent to it, you find out that, yes, 63 is a peak. And you do the 12 again, nope. Then you have 45. Is it bigger than 10? Yes. Larger than 14? Yes. Larger than 23? Yes. Larger than 18? Yes. So this is also a peak. And this one, of course, is not. And this one is not also because this is larger than it. Okay. So for this particular file, it's a good one. It only has 25 elements, so it's relatively easy to pull out. But from that, you can tell these are the peaks. Okay. These two are the peaks, the two ones I put in red. All right. And I can use this data in our in the program to see it work. So you can see that, yeah, these are the two that it pulls out. Okay. So here kind of gives you a quick overview of what we're trying to do, right? So we're going to, and here is like the grid would represent the array, the two-dimensional array that contains our values, right? So if you notice here, you have M keeps track of essentially the row number you're on, and N keeps track of the column number you're at, okay? So if you have a way to, so these are the offsets for the row and the column. So here's like the value that you're checking right now, like I was doing on the example data. Here's the current row number represented by M. Here's the current column number that is represented by N. What you do is you just subtract, compare it to something that has a column one less than it, then we'll compare it to a column, something that has a column one greater than it. And then the row, same thing. Compare it to the row that is one less than it, and then compare it to the row that's one above it. And if this one comes up to be true, where it's greater than all of each of these, right? Then all of each of these, and then it will become the case that yes, that's a peak. Okay. So that's what I'm going to do. Uh, well, this one says maximum size 25 by 25. I'm not going to make something so large. I'm just going to use that data set that I had to go and create this. Okay, so I'm going to go and start Visual Studio. And create a project. And like I said, I'll keep it pretty basic, and we'll go through like a two-dimensional example first to start so you can see that. Console app, next. Put on my desktop. I'll call this one terrain peaks. Okay. Just the usual to get it started. System pause. Gray. Oh, already have that. I'm just going to type hard-coded in, so I won't need a file, but I could use a file because I'm just showing you the conceptually how you do this. So using name space std. Okay, so that's good. Okay, so I just took that previous data that I had and just copied it in because that's what I'm going to use to populate my array. What I'll do is I'll do it step by step, like I said. I'll do a 2D one first. So maybe I'll do like this first row of data, create an array, and then show you how you can find the peak in this if it's only two-dimensional. I'm sorry, if it's only one-dimensional. Which would mean that essentially, you compare the 50 to the 20, then compare the 50 to the 34 and see if it's a peak, depending upon kind of what's next to it. And then I'll build it out to two-dimensional. Okay. So the first part would be we're just going to create an array, and I'll call it grid. That way I can just expand it out, and it's an integer grid, and I'll leave it undefined size here so that it'll set it automatically with the data. So I have 20, 50, 34, 22, 12. Okay, so this is just to start with. We're going to do a one-dimensional just to see it work in one dimension. So I'm going to start with by defining a or do the prototype for a function, and the function is going to be called isPeak, and this is actually the same name they use in the textbook. And what we're going to pass in is we're going to pass in the array. But for now, I'm only doing a one-dimensional array. So, but I'll change this afterwards. So, because I'm only doing a one-dimensional array, and I can call it grid if I want. I can call it the same thing as what this is called. It really doesn't matter. I'll tell you what, I'm going to call it, I'll just call it array. And I'll leave the size open here. So, actually, I don't even need to call it anything yet. I can leave it like that, comma. And then I need to specify essentially the location that I'm going to be looking at. Okay, so this is going to be I'll just say it's I. So I'll do it. Well, I'll do integer for now, and I'll make it I. So there's my prototype for the function that's going to check if it's a peak. Function to check if peak has been found. Okay. All right, so that's what I'm going to start with. So right now I'm going to go down here and actually write the function. And so I'll do on constant. I'll do constant integer because the author does that, and that way it just makes sure that you can't change it inside of your function because we really don't want to change it in this program anyways. So I'll call it AR, comma, integer I. And I'm using this essentially the same variables that they are. The author used grid here. I just AR. We can change it later if we want. Okay. So now what I want to do is basically just, it's going to return true if it is a peak and false if it's not. Okay. So we'll do an if and an else. Oh, if true. There we go. So I'm going to do a comparison. So what I'm going to do is I'm going to say if AR, and this is the location, I is greater than AAR I minus 1, and AAR I is greater than the element just after it, I plus 1. Then we're going to return true, which we don't need these. Return true, okay, because it's Boolean. And it actually would just return a 1 automatically for us, but that's it. We're going to do true and return false if not, okay? Oh, didn't do this here. Okay, and spelling problem here. Okay. All right, so, okay. Oh. This peak. Oh, forgot. Integer. Of course, we need the data type. Integer. Okay. So here's the function that will determine whether or not it's true or false, right? Whether or not it's a peak. And it just returns true or false. Okay, so now what we need to do is actually write the code that will go through each of the elements of the array. So what I can do is I can do a for loop. It works out pretty well. Equal 1, 2, and I'll do one more thing here. I'll say, I'll call it I and call it J. It really doesn't matter. What I'll do is, maybe I'll change my variable name here. I'll just call this as, this would be my column number. So I'll say column equals 1 to column less than, and now it's got to be less than the size. So I'll say column size, but I need to create this. All right, this is a constant, and then I'll just do column plus plus. Okay, so let me go up here, and I'm going to create some constants here. I'll do column size, COL, and I'll just set that, integer column size equal to 5, because I'm only doing a 5 by 5. And then I'm going to do the same thing for row size, because I'll need that later. Row, ROWSIZE, that's also equal to 5. Okay. All right. So my first loop here will be just, make sure this is a semicolon. It's nice, IntelliSense goes through and tells you what's wrong here. Okay, so I'm going to go through this array, and what I'll do is I need to make a call, right? I'll call this function with the array called grid, and also I'm going to pass in the location. Okay, so I'm going to say if, I'll do it in an if function, if selection structure is peak. If it's true, then what I'm going to do, and that's the function, is peak, and we pass in grid, D, comma, and we also pass in column, right, the location. So I'm passing in the location, essentially, of an individual element. So if this is equal to true, and you can actually, you don't even need to write that. You could just say, is grid column, right, like this. You could write it like this. I can even get rid of this. Like that. Then what you're going to do is you're going to display a message. C out. Peak found at location, and I'll just specify equals. And at this point, it's the column, right? Equals to column. And then I'll just do end line. Okay. So we found a peak there. And else, I actually don't even need an else, right? Because I don't want to display anything. Okay, so that's good. And that should work. So let's try it out. So we'll see if it found our peak, which was this one. And that's the only one, right? Because this one's not larger and these are not peaks. So it goes up and then it goes back down. Okay, so let's run it. Okay, so when I run this program, I find that, let me see if I can make this a little larger here. 24, let's say. Okay, so we found a peak at location 1, right? Location 1 is this, the 50 here. Okay. All right, so that appears to work. Let's do one more thing here. Let me make another peak right here. We'll call this one, let's say, 45. So now we should have 2 peaks. So we'll go and run it. And there it is, location 1 and location 3. Okay, so that works. That gives us the 2 peaks here. And this is only in 1 dimension. So now what we want to do is change it to 2 dimensions. So what I could do here is just, I want to take all these other lines here. Let me just copy these down. So I'll do this. And the way you're going to do it is just do it like this. Actually, I should do it one at a time. So I'll do it like this. So this goes here. And then I put a comma. So that's like the first row. And I can just do these one after another here. So let me do one at a time. Okay, so I'll pause it and I'll fill it all in and then continue on. Okay, I went through and populated the array with the numbers that I started off with initially. And one of the things you have to pay attention to when you're doing 2 dimensions is you have to specify, this is a constant, specify the number of columns in your array, okay? And then you'll see I have like double curly brace. So this is like, here's row 1, here's row 2, and then I have them comma delimited here. Here's row 3, row 4, and row 5, okay? So the 5 rows and the 5 columns associated with it. So this is column 0, 1, 2, 3, 4. Okay, so 5 columns there. Okay. So the next thing I need to do is when I actually make the function call, now you'll see we originally has isPeak only has a 1-dimensional array, and we need to change that. Okay, so we need to make this support a 2-dimensional array. And there is one more thing I have to do. I have to take this. Let me cut this out. Put this up here. I have to have them defined before the constants before I actually make the function call. So this is going to be column size. Okay. When you have a 2-dimensional array, you always have to specify the size of the column here. Okay. So when you pass it in, and the reason is the language has no way of telling like how many rows and how many columns, or not how many columns are in your array. So you'll have to define this beforehand, saying like, oh, okay, there's going to be 5 columns in my array. Okay. Otherwise, it would just treat elements as one after the other and consider it to be just like a 1-dimensional array that has 25 elements. Okay. Okay. Let's see, spell that. All right. And then the next thing I need to do is I also need to specify the column and the row number, right, when I pass it in. So I need to do the same kind of thing down here. And I'm going to say this. I'll make this integer j. That'll be the column location. And then here, I need to do the same thing. Do column size on the definition. Okay? All right. So now what you'll recognize is these are not correct here now because they have to be 2-dimensional. Okay? So, but really I'm just going to add this to here, right? And I'll do these first. And there has to be 4 of them, right? Because it's like I'm comparing to the column before it and after it, the row before it and after it. So I have to make 4 comparisons instead of 2. So what I'll do is I'll just copy this, okay? And go out here. I'll tell you what, I'll do a different row here. There we go. So I have 2 rows. Okay. So the first one, what we're going to do is we're going to compare it to the row above it. and itself, right? And the row above it, but the same column number. Okay. The next one, I'm going to do the row after it and the same column number. Okay. And this one, I'm going to make a comparison. Let's see, and I forgot I got to do one more ampersand here for and. I'm going to do the column before it. So I need to specify this is the same row, column before it, which is j minus 1, and then the column after it, which is j plus 1. But of course, it's the same one, right? It's the same row. Okay, so this is the row comparisons, right? It's going to compare the value with the column before it and the column after it. This one makes comparison with the value and the row before it and the row after it. Okay? Right? So that looks pretty good. And now what we need to do, of course, here is now we have this column number. We also have to do another loop because we're doing columns. We also need to loop through and do the rows, right? So we need to go in here, and I'm going to do the same thing here. Control copy. Except now, this is going to be row. R-O-W, R-O-W, and R-O-W right here. So here's the other one. So then I got to pass in. Let's see, the first one, I defined the first one as the row. So I'll do this one. R-O-W, column, like that, and then column. So what did I say? I is the row number. You'll notice here, I is the row and J is the column. So row is going to get associated with I, and column gets associated when it makes the function call with J. Okay. All right. So let's see how that works. Oh, before I test it, there's one more thing here. At location column, let's do this. I'll do this. I'll say at column equal to this. Oh, you know what? I'll do row first. Row equal to row. And then and column equals. All right, how does that look? Column, C-O-L. Okay. All right, so we're going to find peak found at row equal to the row number, and I'll give a space here, and column equal to that number. Okay, so let's see how that works. So our expectation is that, when we run it, if we go back and look at our data, what do we say? We're going to have 40, this 45 is going to be a peak, and the 63 was a peak, right? So these were the two peaks in this file. So if we look at it, this is row 0, 1, 2. So row 2, and column 0, 1, 2. So we should find it at 2, 2, right? At row 2 and column 2 is one of them. And the second one is row 0, 1, 2, 3. So this is row 3, column 0, 1. So column 1. So row 3, column 1, and 2 and 2. So row 2, column 2, row 3, column 1. Those are our two peaks, and so we'll try it out and see how that works. Okay, so we run it. We actually have some other peaks, and there is a change we need to make. I just noticed in the code. This has got to be -1, and this has got to be -1, okay? Save all. And there's one more error here. And it actually works the same because the column and the row size is the same. But this is, let me make this change. This should be row size -1. In fact, I'm going to change one more thing here. I actually want to make this row. The general way we usually follow this, I do row by row, then column by column. So I'm going to call this one column. So this has got to be the row one. So row size here. And then this one is column size, right? So column size. And then, of course, this has got to be my row. And this is my column. Okay. And, of course, these got to be changed. I should have just copied it over, but I didn't. So here we go. So here's the new one. It's all row stuff. Then the next one, the nested loop, is columns. Okay, so make sure this is columns. This one is rows. Okay, now we can run it. And there it is. Row 2, column 2, row 3, column 1. So there it is. So it's a little bit different. It's shorter, a little bit different than the one in this textbook. It's shorter than the one in the textbook. The one in the textbook, they actually open a file and then read it from a file. You could take a look at that and see how that one's done. That's a bit longer. I sort of eliminated that file part and just, hard coded it in directly. When I go in some of the other examples we'll look at, we're actually open a file and then read in a file. But this one is the core to this program. Really, is this comparison right here. Okay, right. You're comparing it essentially by to each element that's adjacent to it. So there's 4 in a 2D array, or at least a two-dimensional map. There's 4 locations that are adjacent to the location that would care about determining whether or not it's a peak. Okay, and that's that.